Okay, next we will consider vertical section plane. So again, imagine reference planes. As you know, this is HP, here it is VP, and the section plane here, it is parallel to VP and perpendicular to HP. So that will be like this. So the section plane is will be like this. This is a type of section plane. Here you can see the section plane here, it is parallel with VP, but it is perpendicular to HP. Here it is such that in top view you see the section plane or the cutting line. In top view we can see the cutting line. Front view you will get the sectional view. As in the previous case, here also you just consider a square pyramid which is resting on HP. The same square pyramid is considered A, B, C, D. Here it is O. Here you can see the section plane cut the base as well as, say, here on the slant edges. If I place the section plane like this, it will cut the base at this point through the slant edges. Suppose it cut the slant edges here. See, section plane cut the slant edges here, so that one cutting point we at here, next is this point, next is here, next point is this one. So in this case the sectional view will be like this. This will be the sectional view. So this is the sectional view. The same thing we can draw here. Draw XY line. Consider the square pyramid. Do slant edges A, B, C, D. P dash, P dash, P dash, C dash, O dash, and P dash. Here you see the section plane. Suppose the section plane is placed such that it is in front of the axis. You can see the axis is through this point, and the vertical section plane is placed such that the section plane is in front of the axis. So here I can represent the section plane like this. Here I can represent the section plane. So here also is a chain line with ends thick. You have to put arrows like this, and here the trace is horizontal trace. Since the section plane is perpendicular to HP, we will get a horizontal trace. So this will be the horizontal trace or the cutting line. So you have to remember this thing carefully. The section plane is perpendicular to HP and parallel to VP, then the cutting line will be in top view and you get the sectional view in front view. But in the previous case, it was a horizontal section plane. Section plane was parallel to HP and perpendicular to VP. In the section plane parallel to HP, the cutting line was in front view, sectional view was in top view. But in this case, section plane is perpendicular to HP and parallel to VP. So this perpendicularity, and since this perpendicularity is there, the cutting line we can represent only in top view. Here the cutting points we mark 1, 2, 3, 4. Say, because all these are visible lines, all these are visible entities. AB is a visible line, AO is a visible line, the next visible line is DO, next is 4. So these are the 4 visible cutting points. The same points, if we project the front view, you see one will come here, because since it is a point, this cutting point is on base, we can represent 1 dash here. Similarly, for getting 2 on slant edge AO, the cutting point 2 is on slant edge AO, so you just project from 2 to cut on A dash O dash. So here this is the point 2. Similarly, for 3 also you can project here. This point is 3, 4 here. 4, cutting point 4 is on DC. Here is the DC in front view. If you join all these points, see, you will get your section view like this. Anyway, we will see these planes in these types of questions in detail. So this case is a section plane parallel to VP and perpendicular to HP. So this is the most important thing you have to remember. The section plane is if the section plane is perpendicular to HP, then the cutting line will be on top view. If the section plane is parallel to HP or perpendicular to VP, then the cutting line will be in front view. So these two different cases you have to say carefully taken. Now next is section plane inclined to HP and perpendicular to VP. Section plane inclined to HP and perpendicular to VP. For that, you just consider a question. Same square pyramid is resting on HP with its base such that the base edges are parallel to VP. One or two base edges are parallel to VP. And the section plane is inclined to HP at an angle of 30 degree and cut the axis at a distance of 30 mm from the base or midpoint of the axis. Just consider the axis height is 60 mm. So through the midpoint of the axis, section plane is passing. So how we will represent that? Here also, let's consider if a section plane is inclined to HP, which means, so you have to draw section plane will be See, the sectional plane will be like this. This is a particular case where section plane is inclined to HP and perpendicular to VP. You see here, this is an inclination with HP and this is perpendicular to VP. So you can see now the section plane is perpendicular to VP and which is inclined to HP. In this case also, since the section plane is perpendicular to VP, the cutting line will be seen in front view. You can see the sectional view in top view. Here also you just consider the square pyramid which is resting on HP with base. Just consider suppose this is a case. Here it will cut differently. So this is one cutting point. Another cutting point, another cutting point here, another cutting point here. So that the section plane, you see the sectional view will be like this. But in the previous case, we got sectional view like this. The section plane was parallel to HP, so that we got section plane like this. The sectional view like this. Here the section plane is inclined to HP, so we got the section plane like this. Now we will draw it in detail. Draw XY line. Square pyramid, side of base 40 mm and axis 60 mm long is resting on HP with its base such that two base edges are parallel to VP. See, A dash, B dash, E dash, C dash, now to draw the section plane, you see the section plane is inclined to HP, so that cutting line should be inclined to XY line in front view. So section plane inclined to HP means you have to draw cutting line inclined to XY line in front view. Suppose the section plane is cutting through the midpoint of the axis. So we just mark the midpoint here. If the height is 60, if the height of this pyramid is 60, at 30 you have a midpoint. If this is a midpoint, then the section plane will be like this. You see, this angle is 30 degree. This angle of section plane is 30 degree. Since it is inclined to HP at an angle of 30 degree, here you have to draw the section plane like this. And you can mark the cutting points. You can mark the cutting points. It is 1 dash. Here it is 2 dash. 3 dash and 4 dash. This AO is the first visible line. The second from say left to right, I am dimensioning it. I am putting the number. That's why from left AO is the first visible line. Then DO is a visible line. Behind DO we have CO. Then again we have BO. Let's say 1, 2, 3, again 4 here. Now you just project these points in top view. So this is 1, 2, 3 and 4. After joining this point, you see something like a trapezium. But then in the previous case, where section plane parallel to HP, you see this was a square. All sides are equal. In the previous case, where section plane was parallel to HP, this was a square. But in this case, you see, after joining these 1, 2, 3, 4 points, you will get a trapezium. Now, just erase all these inner lines, inner slant edges. Now you have to hatch it like this. But here one important thing is the sectional view you obtained is not a true shape. To obtain the true shape, you have to look from this direction, that is exactly perpendicular to the section plane. See, because the section plane is inclined like this, to obtain the true shape, you have to, the direction of view should be perpendicular to the section plane. You have to look towards this direction. But while projecting, what will happen? While projecting, this true shape will shrink in between this projector, in between these projectors. So the shape obtained is not a true shape here. If the section plane is inclined to HP and perpendicular to VP, the sectional view obtained in top view is not a true shape. In that case, we have to draw a true shape of the section also. So that there are two methods to draw the true shape. I will explain both methods. First, what you need to do is, you just take the distance of these cutting points. The limits of these cutting points 1 dash 4 dash and 2 dash 3 dash, where the section plane is cut to the solid. So you have to keep this is the distance of the cutting plane on the solid. You just take that distance from compass and mark it on the XY line. You just mark that points in XY line, suppose here. You see, I take this distance and mark here. This distance and I mark it here. Similarly, same, what you have to do, write down the points also, the cutting points also, that you may make mistakes there. So 1, 4 here, this 2 dash 3 dash here. Now from this 1, 4, you just draw perpendicular projectors, and from this sectional top view you can construct horizontal projectors. See, from 4, from 3, from 2, from 1 also just construct perpendicular projectors, horizontal projectors. After completing this, we just mark the coinciding points. So 1 dash, the perpendicular projector, and horizontal projector from 1, you will get the section point 1 here. Here, the section point 4, the 4 dash perpendicular projector and horizontal projector from 4 you will get here. This point is for 3 and this point is for 2. Just join it. How to use scale to draw it properly. See, this is a true shape obtained. You have to hatch it here. Hatching means just draw lines, parallel lines. You keep the distance as a maximum 2 to 3 mm, and the angle or inclination of this line is 45 degree to XY line. Just keep it like that. Now just complete the true shape. You have to realize one thing. What a true shape means, actually you have a sectional top view. You just extend you just enlarge the sectional top view to this distance. Now this is the actual distance of the section plane. While projecting, the shape or the sectional view is shrink to this projected distance. Now for a true shape, what you have to do is take this shape and extend to this length, so that you will get a true shape. That is the concept of getting true shape.